Well, good morning again, everybody, and we're back to the same objectives we've been staring at now for 3 days, but we should really be feeling like we're getting this trigonometric functions at any angle down, the real numbers, hey, that's working for us. It's just these last two pieces here, you know? So today we're going to talk a lot about periodicity. And periodicity, it's not that bad a concept if you're looking at a graph, but there are some pieces to it that you're probably going to want to memorize. The good news is it's not a lot of stuff. And then starting our work on the unit circle, I think I'm going to hold off on that until tomorrow. You know, yesterday just felt kind of discombobulated. Did you feel that way? Like yesterday was just kind of weird? So I'd rather, just cover like one chunk of this today and say, hey, you've got some work time. Let's get used to all of the changes that have happened over these last couple of days. And then tomorrow come back and really hit the unit circle hard and go after it. So in my notes, this is way back here at page 10 that we ended. And like I said, periodicity it's not a tough concept. But we have two different ones. And so what happens is some people tend to only remember one, and then, of course, that messes them up when they're studying another one of the trig functions. So periodic functions, we'll start with sine and cosine. Those are part of our primary trig functions. Sine and cosine, remember, get that special name. They're called sinusoids. And sine and cosine functions have a period of 2 pi. Tangent 1 pi. So that's the thing that sometimes, because we don't use it a whole lot, people have trouble with. They're like, oh, aren't they all 2 pi? No, tangent is not 2 pi. So like it says, these predictable repetitive behaviors help us model behavior in the real world. For those of us that are really visual, this is not going to be a problem at all. Because what we're talking about when we talk about periodicity is, if you had to copy and paste and get the entire graph of cosine, the entire graph of sine, the entire graph of tangent, how much would you have to take? So when I look at cosine, I think, all right, so what I need is one chunk that copy, paste, copy, paste, copy, paste would do the whole thing. So let's see, this is the low part. So if I take the low part and go all the way back to the low part, that should be enough. Because then if I move it from side to side, I should be able to get the whole thing. In fact, let me show you that. So if I move this over, that would give me the next wave to the right. I can take it over here and get the next portion of the wave to the left. So how big a chunk was that? And it always has to do with the x values. That's how we get the period. So this was at negative pi, this was at 1 pi, and I want to know the distance between those two. 1 pi, 2 pi. That's the distance. So it's 2 pi. Over here for sine, do the same thing. Figure out what the chunk would need to be. This time, just for some variety, I'll go high to high. Again, can move it to the right and see that's going to join right up. Move it to the left. Perfect position. But now how much was that one? And this one for my x's went from negative 3 pi over 2 to pi over 2. So if we wanted to find the distance, we do that. To find distance, what you do is you find the difference between those two positions. And of course, minus a negative is going to make this a plus. That'll give us 4 pi over 2, which is 2 pi. So like I said, for visual folks, it's a little bit easier to remember the sinusoids, cosine and sine. Hey, that's 2 pi. Then we get to tangent. And tangent looks so different that, yeah, it is easy for people to forget it's that different. I mean, it really is. So the piece that I would need to copy and paste for this one would be just one of those waves. And then I could move it wherever I needed to go, right, left, finish it off. And we can see here that they've tried to help us by kind of showing us where the vertical asymptotes are going to be for tangent. That this is between negative pi over 2 and pi over 2. So we do the same thing. And minus a negative would make it a plus. And we only get 1 pi. So if anybody messes these up by the time we start taking tests on graphing, which is going to be the next set of units from Chapter 4, the next sections, it's always this one, you know. People seem to memorize the 2 pi thing, and then they forget tangents are not part of the sinusoids. The sinusoids are 2 major trig functions out of the primaries, are cosine and sine, and those are 2 pi. Tangent is 1 pi. Their reciprocals work the exact same way. So cosecant, actually this one would be the flip for cosecant, and secant, those are 2 pi. Their period is 2 pi. And cotangent is 1 pi. Again, we'll be talking about it a lot when we do the graphing. But seeing the graph really helps when you're thinking about the periodicity. Because this, it just looks like any other paragraph we've ever seen. So it's hard to remember, hey, this was really important. They told us 2 pi for cosine and sine, and tangent is just 1 pi. But that's the periodicity. So the fact that we have this repetitive motion, these nice repetitive curves, is what's creating a periodic function. A function y equals f of t is periodic if there's some positive number c such that when we move it over, f of t plus c, so whether or not it's a left or right movement, it will still equal f of t for all values of t in the domain of f. The y's will match up, and that's what's happening when we're moving this. They're matching up. So the smallest such number c is called the period of the function. So the period for sine and cosine, 2 pi. Period for tangent, 1 pi. And this behavior, like it says, also helps us train ourselves when we can't use a calculator. And really, for most of the material that we cover in Chapter 4, we don't want a calculator. This is all about perfection. This is about math that's been around so long that it was studied when people were still counting rocks, for goodness sake. So we're supposed to know these perfectly and elegantly. So this one, I keep thinking, I don't know why we took this out of your packets. Were they seriously that long, that one more page with a couple? Because isn't this really helpful to see it when you're talking about period? Maybe I'll put that back in next year. Nobody else has to, but I'll sneak mine back in. All right, so in example 8, we're going to use periodicity. And it says, find each of the following numbers without a calculator, and you look at it and go, what? Yeah, how am I supposed to do any of that? Look at those numbers. But then, I'm going to take a peek again at that graph. And I notice what happens every 2 pi. From here to 2 pi, notice how the y's are exactly the same. It's landing in exactly the same spot. That's what a period is telling us. Same thing here. This spot, 2 pi later, is in the same spot. Oh, wait. That makes perfect sense when you think about the unit circle, doesn't it? Because it's here, and if it goes 2 pi, it's right where it started. So they are linked between each other. These points, in fact, are points on the unit circle. That's where we get all of that from. So, what does that mean for us? It means something that's looking very difficult like this should not be. Here's why. We just have to figure out, does that go perfectly in multiples of 2 pi? Am I landing in exactly the same place as I started? If I'm not, how much farther do I need to go? That's the piece that we need. So with this, there's always those people that look at that and they say, well, Cedarholm, that's not going to land perfectly because it's not even. Everybody realize all even numbers are divisible by 2 evenly, right? So if you look at this and you get to the end and you say there's a 1, that's not going to go in perfectly. But let's just say you didn't see that and you decided, I'm going to go ahead and just by hand, real quick, do this division by 2. Just to show, prove yourself that this is not going to go in perfectly. So if we were looking for a rational number, a fraction, we'd want to change it to a decimal if we can't use a calculator and just think about where that would be. So 2 goes into 5 twice. You do your subtraction. 2 goes into 18. Sorry, 2, I'm thinking about the 17 and thinking about 2 times 9 is 18. 16, so we've got 2 times 8 is 16. It's hard to slow down sometimes with these little things that we're doing. And then we've got an 18, so there's our 9. We bring down the 0, can't do anything with that. And we have a 1 for a remainder. Now, remember that plus 1 is going to be 1/2. So here's what I'm looking for. Is this 2,890 piece in there? I didn't miss a 0, did I? I did. Forgot to write it down. That was a 0. That was because of my remainder there. Is that even? Okay, so for that part, it would land at exactly the same part it started, because if we had 28,900 pi, we could divide that perfectly by 2 pi. But this little remainder, that's the part we have to take care of. So this would be pi over 2. The rest of it's going to land exactly where it started. So we have to know the sign of pi over 2. So start thinking, pi over 2, let's see. Pi over 2, well, pi is all the way across. Oh, that's 90 degrees. Oh, wait a second, that's quadrantal. So with quadrantals, I'm supposed to use the coordinates. So that would be 0, 1. And because of something that we learned yesterday, this is even easier than using the coordinate trig. Because yesterday we learned that all of these points on the unit circle are the ordered pairs cosine of theta and sine of theta. Hey, the answer to this is 1. The sine of pi over 2 is 1. Now, it wasn't pi over 2 that they asked us for, so we have to write the original, make it fancy. That was truly what they were asking for, the sine of 57,801 pi over 2, and that's 1. So like I said, some people, after you do enough of these, you'll just look at it and you'll go, okay, that's going to be divisible by 2 until I get to that last piece right there, that 1. That's going to be my remainder, and you'll go from there. This one, a little bit tougher, but let's look at it. Cosine of 288.45 pi minus the cosine of 280.45 pi. So what are we going to do, Cedarholm? I mean, if we follow the order of operations, we have to figure out what the cosine of 288.45 pi is. Then we have to figure out what the cosine of 280.45 pi is. And then we have to do subtraction. Or we notice this. How far away from 288.45 is 280.45? 8 pi. So I should do doubles there. Well, what's 8 pi going to do to it? take your point, and if you go 8 pi, won't you land at exactly the same spot? So it doesn't matter what the values are. This value is going to be exactly the same thing as this value. It's going to be 0. All because 8 pi is divisible by 2 pi. Perfectly. It's going to land in the exact same spot. So it takes a little more thinking outside the box for one like this. But when they're asking you questions about numbers where you go, oh my goodness, look at all that mess, you should think, oh, this is a trick. Because I'm supposed to know that the period for cosine and sine is 2 pi, and I'm supposed to use that. Now switch gears. This is tangent. So what do you switch in your brain to think about this one? 1 pi. 1 pi. Which actually makes these kinds of problems even easier. Because this one says we're supposed to figure out the tangent of pi over 4 minus 99,999 pi. Does it matter how many pi's are back there? Doesn't matter at all. The y is going to land in the exact same spot. So they may give us this big fancy 99,999 pi, but they are really just asking us for the tangent of pi over 4. That's what they're asking us. So with this one, always make a sketch. If it doesn't come to you immediately, make a sketch. That's how we do this. So we start thinking, well, pi all the way across, pi over 4, oh, that's a 45-degree angle. Oh, wait, I can draw my reference triangle and I can figure this one out really quick. So that's my 45, 45, 90. And 45, 45, 90, these are easy to name, for it's 1, 1, square root of 2 in a triangle game. Well, tangent is opposite over adjacent. That's 1 over 1. It looked really fancy, but the answer's 1. And there it is. So that thinking about, okay, even for cosine and sine, that's going to mean that 2 pi is going to work out really nice. With tangent, it does get a little easier if you remember. It's 1 pi. That's it. That's the periodicity. So now we would definitely be set to start looking at the unit circle. So at this point, we should be able to use our reference triangles, our quadrantal angles to evaluate the trig functions for anything that has to do with multiples of 30 and multiples of 45. And if you're thinking, Cedar, where's the 60? 60 is covered because it's a multiple of 30, you know. So we'll be able to do 30, 60, 90, etc. and go all the way around the unit circle. And tomorrow, we're going to do that without looking at that. And we're going to find it's not that hard to come up with the numbers that you need for the unit circle. There's a lot of symmetry taking place on there, you know. And yesterday we talked about how cosine and sine are now going to be between -1 and 1. When we were just talking first quadrant and reference triangles, we had that limited between 0 and 1 because opposite and adjacent are always smaller than the hypotenuse. But now we're going to swing through all of the quadrants. So cosine and sine will go from -1 to 1. So this diagram, it says, is given so you can visualize all of the trigonometry that we would now be able to do. We're not going to use it. We're going to make sure that we are still drawing our reference triangles at this point. Whenever you're doing the assignments, think drawing to get it started. Because tomorrow, we're going to create this, and you're going to realize, oh my gosh, I know all that stuff. I know how all that works. And then we're going to start trying to figure out cosine, sine, and tangent for pi over 4, for pi over 6, for pi over 3, for all of those. And we're going to see that we're going to get faster as we have more experience with these. But for today, for your homework, let's go here. And tomorrow we'll jump in to the unit circle piece. Oh, please make sure that you bring, there's a worksheet that has the unit circle on it for tomorrow. Looks like this. And there's another one that has lots of trig pages on it. In fact, let me pull those up because you probably took those home already. Google Meet people, please don't sign off yet because I have something else I have to ask you to do. I'm just waiting for everybody to write this down. At the end of any college course that you take a course survey. And in that course survey, you ask questions about, was the book helpful? Were the materials on the internet helpful for the course? Was your instructor knowledgeable? All of those types of things. And last year, a lot of people around the state had said, why do we wait until the end of the year? Because we have 2 semesters at our school, or we have 3 trimesters at our school. Can't we do this each trimester, each semester at the end of the year? So this year, first time ever, Pine Tech is asking you, based on your first semester teacher, to take a survey, your first semester materials and first semester instructor. And just yesterday, they sent me the, hey, it's okay to hand this out. So way down at the bottom, there's a pink folder, Pine Technical and Community College Survey, and anybody that is taking it for college credit, they don't want the people that are not taking it through Pine Tech to do this, but anybody who is, they want you to fill out this survey. We don't get to see all the questions they ask. Usually students can finish it in 5 to 10 minutes or whatever, so they'd like you to do that. So add that to your list of to-dos. And then I wanted to pull up that worksheet. Come on, go back, Schoology. No spinning wheel of death. So digital copies of worksheets and handouts. So tomorrow, here we go. So here's the unit circle worksheet, which again, you've got in your pile. I just showed you that one. Google meters. I don't know if you can even make that out from where it is. I'll move it back here. It says fill in the unit circle. You'll want that one tomorrow. And then the one that says time trigonometry worksheet. Oh, good, it is yellow because I was going to tell you to look for yellow. So you'll see this is where we're going to be filling everything out tomorrow and then working from there. Should be right after the white worksheet in that pile I gave you that says fill in the unit circle. Otherwise, like I said, I think it's a good day for me to hit the lights and you guys can start working on the assignments, start feeling like things are maybe slightly normal. I know it's still kind of weird. And again, put that survey on your list of things to do if you're getting credit from Pine Tech. Okay, Google Meet folks. So whether or not, again, you're always welcome to stay on and work on the assignment and ask questions, or you're also welcome to pop off, work for a little while, and come back on. You'll probably just have to get my attention by yelling Mrs. Cederholm when you come back in.